Good crops depend on good soil, but it's more than just nutrients. Soil pH also plays a role. Here's Sunup's Austin Moore to explain.
Simply put, soil pH is a measure of the amount of hydrogen in the soil.
More hydrogen, the pH falls below 7, it's called acidic. There are more hydroxyls or OHs in the system, it means it's basic, above 7.
With Oklahoma's widely varied soil compositions and types, we naturally have a wide-ranging variety in soil pH. But our agricultural practices can push those differences even further.
When we apply nitrogen in the form of ammonia or ammonium, the transformation of it into nitrate releases hydrogen ions into the system. That hydrogen ion increases the concentration of hydrogen ions and lowers the pH. Additionally, as we take harvest off, whether it be biomass, grain, or fiber, as we remove that from the field, we're removing base cations with it. That is the calcium, the magnesium, and the potassiums, which hold the pH stable. As those are moved away, they're replaced with hydrogen. And so with that, we have a lowering of pH.
That acidification of the soil over time does matter because our crops each perform better at the right pH.
If you're a wheat only, that is the only crop you're concerned with, that optimum range is about a 5.5. However, if you have rotation or if you look at other crops, many of those crops would prefer a pH of 6 to 6.5. Canola, alfalfa, soybeans, and corn perform better at a 6.
The problems of acidic soils build beyond the crop itself, because the herbicides we use to control weeds are rendered less effective in lower pHs.
So for the ALSs, actually acidity can affect part of those herbicides in a way where it's going to decrease their half-life, meaning when 50% of the herbicide breaks down in the environment. A pH above 5 for many of our sulfonylurea or ALS herbicides, those are going to break down in less than 2 weeks. Whereas we would typically expect to have them in our soil profile for 8 to 10 weeks, and at pHs that are near neutral, 7 to 7.5, we would have them for 7 to 10 weeks. So just dropping that pH by 1 point or 2 points really affects how long you're going to see control from these herbicides.
Which affects the bottom line.
If you pay for a herbicide, you put it out on your field, you have a low pH but you didn't necessarily know it, or you didn't soil test this year and adjust for it, then you've spent money that's essentially going to be wasted because that herbicide is going to break down much too quickly.
There is only one cost-effective option for moving acidic soil back towards neutral: the application of agricultural lime.
Liming is neither an immediate fix nor is it a short-term fix. When you apply lime in the system, it has to be degraded through water. So many people may have applied lime during the drought a couple years ago or the current ongoing drought. Without rain, without water to break down that lime particle, the soil pH doesn't change. In a typical year in Oklahoma, it will take agriculture lime somewhere between 100 and 200 days to completely break down. That is with good moisture. That's with a consistent rainfall. However, this does not disappear within 100 to 200 days. Many lime applications, you apply lime today, you have impacts as far out as 8 years. Typically, we allow for about a 5-year impact on that field. So that one-time cost you lay out this year for lime can be stretched out economically over 5 years of return.
While nitrogen and mobile nutrients such as sulfur need to be tracked with yearly soil samples, Arnall recommends sampling for pH, potassium, and phosphorus only every 3 to 4 years. For Sunup, I'm Austin Moore.